So for 7.1, we're looking at square roots. And the idea of a square root is this. Because 2 times 2 gives us 4, then we say the square root is equal to 2. Now, likewise, we can say this. -2 times -2 is equal to 4. Then, and this is sort of how the text does it, the negative square root of 4 is -2. So that's sort of how they go about it. Now, there's something else. Let me continue on, because 5 times 5 is 25. Then the square root of 25 is 5. So this is the idea of square roots. Now, in this section, we're talking about roots in general, so we better talk about other kinds of roots. Now, since times 2 is 8, now we have our 3 2's. So this time we're not talking about a square root, we're talking about a cube root. So then the cube root of 8 is going to be 2. Now we can do other cube roots. Since -3 times -3 times -3 is -27. You can work that out on a calculator or on paper. This means the cube root of -27 is -3. And then let's keep going. Say we have this. Talk about fourth roots. Since 10 times 10 times 10 times 10 is 10,000, then the fourth root of 10,000 is equal to 10. And likewise, since 2 times 2 times 2 times 2 is equal to 16, then the fourth root of 16 is equal to 2. So this is the idea of roots. It's figuring out when we have the same number multiplied to itself. If we have 4 of these, they're going to act as a fourth root. And the product, if we take the fourth root of that product, well, we get that base number that we were working with. So I'll do one more, a couple more. Let's go fifth roots. So if we multiply 5 2's, we're going to get 32. So this means the fifth root of 32 is equal to 2. Finally, let's take a look at this one. Since 1 times 1 times 1 times 1 times 1, if you multiply a bunch of 1's together, you just get 1. And the fifth root of 1 is equal to 1. So, any questions about that? All right. So let me show you some interesting ones. So for example, let's say you want to find the square root of 1/4. Now admittedly, you want a little bit of experience sort of playing around with multiplying numbers. We make this note. 1/2 times 1/2 equals 1/4. That means square root of 1/4 equals 1/2. Now let's take a look at another one. Find the negative square root of 1/9. There's two ways of doing this. One, you want to find a negative number times itself that equals 1/9. So there's a negative times that same negative is equal to 1/9. Now, what negative number times itself gives you 1/9? Well, negative 1/3 times negative 1/3 equals 1/9. That means the negative square root of 1/9 is negative 1/3. So you can think of it like this. Now, there's another way you could think of this. If this negative and positive thing is going to get confusing, and it can in a little bit. The other approach is take negative 1/9 and let it be negative times the square root of 1/9. Then we can just think about the positive. So since 1/3 times 1/3 is 1/9, then negative 1 times the square root of 1/9 is negative 1 times 1/3, or negative 1/3. You're going to get the same answer. So any questions about that? Now, there is kind of an issue when you take square roots or even roots and odd roots. So your even roots is the square root, or sometimes we could write it as the 2 root, but for reasons I think of just convention, we don't. Then there's your 4th root, your 6th root, and they go on and on. These are your even roots. So 2, 4, 6, 8, 10, 12, and so on. Now for your odd roots, root 3, root 5, root 7, and so on. So those would be your odd roots. Now, with the even and odd, there's going to come up an issue that we'll sort of resolve in the last section, but it's going to be this. You cannot take even roots of negative numbers. You cannot take even roots of negative numbers. So you can't find the square root of negative 16. Now you can do the negative square root of 16, but you can't do the negatives. You can't do the square root of negative 16. And we'll do an example, sort of separating those two out. But you can take the odd roots of negative numbers. That's okay. So if you can't take even roots of negative numbers, you can take odd roots of negative numbers. Now, why is this? Well, let me give you an example. So let's take a look at the square root, or the 2 root. We'll use this as sort of our stand-in. And let's take a look at the square root of 4. Well, it's equal to 2, since 2 times 2 is equal to 4. Also, it has 2 square roots. There's a negative square root. This is because negative 2 times negative 2 is equal to 4. Oh, sorry. Now, the whole reason why the square root works, this number is the same as that number. This number is the same as that number. So you can have a positive square root, you can have a negative square root. That's fine. But once the negative moves on the inside here, that's when things start to fall apart. So let's consider the positive square root of negative 4. Well, what would this be equal to? Well, since negative 4 is equal to negative 2 times 2, this does not indicate a square root, because negative 2 is not the same as 2. We can only take square roots if some number is the product of, well, the same number times itself, its exact self. And the thing is, in a product, at least when we're dealing with real numbers, and this will come up in section 7.7, we need a negative times a positive to get a negative. These are always different. So that means we don't have the same number times itself. So that means there is no square root. Now in section 7.7, this is going to change. We will be able to take square roots of negative numbers, when we allow for what are called complex numbers. So for example, since 2i times 2i equals -4, then the square root of -4 equals 2i. We got to talk about what I is. We're going to do that in 7.7. So we don't have use of I numbers yet. So for now, when we look at even roots, we don't want to take square roots of negative numbers. Now, even roots will give you a positive root and a negative root. That is possible, but the negative has to be on the outside of the square root. It can't be on the inside. Now let's look at odd roots. Let's take the cube root. Well, the cube root of 8 is 2 since 2 times 2 times 2 is equal to 8. But here's the thing about cube root and negatives. This is equal to -2. You can have a negative on the inside since same number, same number, same number gives you -8. So the moral of the story is this. Even roots, you won't be able to take the square roots of those, at least not yet, or even roots of those. But you can take the odd roots of negative numbers. That's okay. You just can't take the even roots of negative numbers. So let me do another example. Let's say we have this. Now, later on, what we're going to learn is we can treat this is 144 plus 25 to the 1/2. And we're going to find that out in section 7.2. But for now, what we're going to say is this. As much as you can, try to simplify inside the radical first. So you can sort of treat like there's parentheses on the inside. Now 144 plus 25 is 169, and we're taking a positive square root. So one number that multiplies to itself to give you 169, 13. So that's going to be your answer. Now let's take a look at this. Now what if we change things up? Now in this case, what we're going to do, again, we're going to compute what's in the square roots first. Now 12 times 12 gives you 144. So that means this is going to be 12. 5 times 5 gives you 25. So the square root is going to be 5. And that's going to be 17. All right. Now we do get into what we call a square root function. And the thing with the square root function is going to be this. The square root function this is one of your canonical functions in algebra. That means this is one that will build other functions out of it. And what it looks like, if you were to graph it, it looks something like this. Now, why is that? Well, what you can do is do an XY chart. X, f of x. So if you let x be 0, 1, and we want to be able to take the square roots of these numbers. I'll talk about numbers later that we can't quite seem to take the square roots of. Not because they're negative. They have irrational results, and we'll talk about that later. Let's say 4 and 9. Let's do square roots that won't give us irrational results. So what number times itself gives us 0? Taking the square root of 0, well, that's going to be 0. Now we're taking the square root of 1. Well, what number times itself gives you 1? Well, 1 times 1 gives you 1. So where's 1? Taking the square root of 4. A number times itself, it gives you 4. Well, that's 2. 2 times itself, 2 is 4. And same thing here. 3 times 3 gives you 9, so the square root of 9 is going to be 3. So if we graph these, we have 0, 0. On this f of x. This is our x. Then 1 and 1. All right. 4 and 2. So here's 4. We'll go up 2. And then 9 for x and 3 for f of x. I think there's going to be some, wait a minute. There we go. And this would be f of x. Square root of x. So that's how we come up with this graph. Now, there's some rules with the square root of x, and it comes from our experience of trying to take square roots of negatives. For now, we don't. But later on we can. We're going to make this point. For f of x equals the square root of anything. What's inside the square root must be greater or equal to 0. So when we talk about the domain, we want to make sure that whatever's on the inside is greater or equal to 0. So let's say we have something like this. So first off, let's say we find f of 1. Oh, let's go f of 0. Let's do that. Let's go f of 0. Well, we treat this like we treat functions in the past. We're going to replace all the x's with 0. So 0, 0. Gives us 4 minus 0, or the square root of 4. What number times itself gives you 4? Well, that would be. And that's going to be your answer. Now, another question we might have for this find the domain. Well, the rule is going to be this. We want whatever is in here to be greater or equal to 0. So the way we need to find the domain, we need to state that fact. So 4 minus 2x must always be greater than or equal to 0. And we're going to solve for x. Because this will tell us about x, what it can be and what it can't be. Now, since we're dividing by a negative, we're going to switch the inequalities on. And so what we're going to get, the domain will be x less than or equal to 2. Or, put this on a number line, we're going to do include 2. And since x is less than, we take everything to the left. This interval will be negative infinity, comma, 2 with the bracket. That's going to be your answer. So any questions about that? All right. So let's see. Now, one of the things that's going to come up, and it's a special kind of function that it's going to work like this. It's the nth root of a to the n. So this is a topic in and of itself. And it's going to work like this. Let's consider n even. So let's say we do this. The cube root, oh, I'm sorry, root even, fourth root of 2 to the 4. Now this is a positive root. So we're going to get the fourth root of 16. And, well, 4 2's, if you multiply them together, you'll get 16. So that means the fourth root of 16 is one of those 4 2. All right. And now here's something that might seem kind of dicey. Now again, this is a positive root. So if we take this to the fourth power, negative 2 times negative 2 times negative 2 times negative 2 is going to be 16. So you might say, well, since we have 4 negative 2's, then the fourth root would be negative 2. This is where the book's notation with that minus becomes important. They differentiate between the positive root in the negative root, with positive having, well, nothing in front of the radical. And the negative root having a negative in front. This is a positive root. So the way to read this is the positive even root of 2 to the 4, positive even root of negative 2 to the 4. Now, how can you do that? Well, negative 2 to the 4 becomes 16. So now what you're asking for is the positive root of 16. We do know what that is. For the fourth root, it's going to still be 2. So this not having a minus here is important. So now, for even roots, this is what we're going to get. When n is even, you're always going to get the positive version. What kind of function does that? The absolute value. So this is a very sort of complicated way of doing the same thing the absolute value does. Now let's take a look at n being odd. Now let's say we have the cube root of 8. Well, this will come out to be, oh, sorry, I go back up. Cube root of 2 to the 3. And this is the cube root of 8. And the only way you get an 8 with 3 numbers that are the same is 2 times 2 times 2. There's no other way to get the 8. So this will come out to 2. Now, here's what's a little different with negatives. Negative 2 cubed is negative 8. Now, it is okay to take the odd root of a negative number. The only way, though, and the thing is, we're not going to worry about this whole positive root business here. So what we're going to look at is, for odd roots, and it's just something we're not going to worry about, what 3 numbers that are all the same multiply the negative 8? There's only one type of number that does that. And that's negative 2. So what we're going to get is this. When n is odd, it just kicks the number right back out. So let me do some examples with this. This is one of those things you definitely want to practice to get the hang of it. So for example, the square root of 5 squared, that's going to be the absolute value of 5, because the square root is an even root, 2 and 2, and you would just get 5. But the square root of negative 4, this will be the absolute value of negative 4, or just 4. Now let's take a look at odd roots. For an odd root, let's say the 5th root of negative 1 to the 5th, well, you just kick the number out. It's just going to be negative 1. Or the 3rd root of 10 cubed, we'll just kick out the number. We'll get 10. So when you have the root and the exponent, root and exponent repeated this way, If you're dealing with even numbers, you have an absolute value. If you're dealing with odd numbers, you just have the number pass on through. Now these get a little more complicated. Let's say we have this. Now what you can do with this, you can rewrite it as 10 x cubed squared. Now I'm kind of in favor of this. If you think of it like this, I think this problem becomes easier. You have a root 2 and a 2. That means we're taking the square root, or the absolute value. So we could just put a negative like so. Now, the 10's always going to be positive. So now the x might not be always positive. If we choose -1, -1 cubed is -1. We would still need to take the absolute value to make everything positive. But since this is already positive, we can pull it out. Now this we've declared to be negative, so we're just going to leave it that way. And that's going to be your answer. Let's do another one. Let's say we have this. Now this one we can use factoring on. Two numbers that add up to 14, but multiply with 49, 7 and 7. Or so this is what we've got. Root 2, 2. That means what is ever on the inside, we take the absolute value of it. And that's going to be our answer. So questions about that? All right. So let's see. Now, if we go to odd roots, well, let's do another even root. Let's say we have this. Well, again, the root and the exponent match, and because they're even, we're just going to get the absolute value of whatever is on the inside. Now, if what's on the inside is odd, now this one takes a little bit more. -32 x minus 1 to the 5th. -32 is -2 times -2 times -2 times -2 times -2, or -2 to the 5th. So what that means we can rewrite this. Or we can write it like that, where we would distribute the 5 as an exponent to get this. And then negative 2 to the 5th gives us negative 32. So since they're odd root, odd exponent, and the odd root and the exponent match, this just passes through. That's going to be your answer. So just let's see, how are we doing on time? Okay. So that's going to be it for section 7.1. Let's look at 7.2. And 7.2, a lot of 7.2 is it's material from chapter 1. And that means that it's the exponent rules. And we'll see some of those again. But they do have a summary of those on page 519. That's where you'll find a summary of those exponent rules from chapter 1. Now, let's take a look at something. Let x equal, let's see, 8 to the 1/3. Now, if we cube both sides, we'll get x cubed equals 8 to the 1/3 cubed. Now we'll distribute this as an exponent. You'll get x cubed is equal to 8 to 1/3 times 3, or x cubed is equal to 8. So what does this say about x? Well, it says that x, we take 3 x's, multiply them together, we get 8. Or, put another way, the cube root of 8 is equal to x. So what does this tell us? Well, cube root of 8 is equal to x, but we said that x was equal to 8 to the 1/3. Put another way, the cube root of 8 is equal to 8 to the 1/3. So what it says is this. A to the 1 over n is the nth root of a. So that's what these nth roots mean. So let's compute some of these. Let's take a look. So 100 to the 1/2. Again, a to the 1 over n is the nth root of a. So 100 1 over 2 is the 2 root of 100, which is the square root of 100. And let's see, what number times itself gives you 100? 10. And since this is a positive even root, we'll go with the 10. Let's take a look at another one. So negative 64 to the 1/3. Well, again, what this means is the cube root of negative 64. Now, this is an odd root, so that means we can take the root of the negative number because it's odd. If this was even, we couldn't do that, at least not until section 7.7. So what's the cube root of negative 64? Now, this might take some playing around with the calculator. A hint on this is because it's a cube root and it's negative, we're going to be doing some negative numbers here. And this is what we're going to find eventually. If you take negative 4, take 3 of those, multiply them together, you'll get negative 64. So that means the cube root of negative 64 is negative 4. So this is just a fancy way of saying we're taking a root, and that's it. Now, where this gets a little interesting is when we mix things up. Let's say we have something like this. Now we've got the 3 halves. Now, in our little formula that a to the 1 over n is the nth root of a, we had 1 over n, not 3 over n. So this is what we can do. We're going to use those rules from chapter 1. And we can rewrite this as 25 to the 1/2 times 3. Because 3 times 1/2 gives you 3 halves. So, knowing we can do this, we can use our rule to say this is 25 to the 1/2. And whatever that turns out to be, we're going to cube it. Now, 25 to the 1/2 is the 2 root of 25, or the 2 root's just the square root. Square root of 25, and we're looking for the positive root. It's 5, and then we cube 5, and that turns out to be, well, 5 times 5 times 5 is 125. And so that's going to be our answer. Now, this is the easy way. We could do this the hard way. Let me show you. We could have said this because multiplication's commutative, the order doesn't matter. So what's 25 cubed? I'll calculate this one. Let's see here. $15,625. If we take the square root of that, And if you're really hard on your luck for a square root or even a cube root, you can use a scientific calculator. They usually have those on there. Let's see. I think this one has that on there. Well, it's going to be 125. Yeah. Ooh. Yeah. You're going to get the same answer, 125. So depending on which road you take, this one I think is harder. If you don't know, I mean, since we've done it before, we should know that the square root is going to be 125. But if we didn't do it before, we'd have to figure this out with a calculator. And then what we're going to get is probably a harder way to go. So depending on which route you take, one might be easier than the other. So the way this sort of boils down is this. Is that you can take a to the m over n, and you can do the nth root of a, figure that out, give an exponent of m, or you can compute a to the m and take the nth root like that. So any questions about that? All right. So that's kind of the as far as the numerics go. Now you do have some interesting algebra here. So let's jump into some simplifications. Let's say we have this. So now we're going to be working with variables. Now, same thing as before, just another name for the root. That's all that is. Now, let's say we have something like this. Now, what the book typically wants from you, in this case, is to have the power inside a root. They tend to want you to do the root last. And that's going to make sense, certainly with something like this. Well, maybe not always makes sense, but that it is what they want to see you do. So what we'll do is we'll keep xy to the 9th. Oh, sorry. We'll keep xy to the 4th. Have the root like that. Now, if I draw this out a little bit more, we go step by step. Instead of using the formula, what we're going to get. So either way, you could just jump down to here using the formula. But for this type of problem, they want you to have the power on the inside. Let's see. And it actually does make sense to do that. If x and y were negative, or if x was negative and y was positive, x times y would be negative. But if you take a negative number and you give it an even exponent, it wipes out the negative. So that allows you, if you're going to take an even root, you don't have to worry about taking the even root of a negative number. Now we had an odd root, a root 9, and well, in that case it wouldn't matter. But if you have something like this where you have an even over an odd, if you have the even, well, I guess it wouldn't really matter in this case. Let's see. Let me switch that up. If you have an odd even, I guess that won't make much of a difference. Yeah. Sorry, I'm trying to see where they're getting at with this, but okay, we'll move on. We'll move on. But that is what they want. They want the power on the inside and then the root on the outside. Now, let's say we go in the opposite direction. Let's say we have the cube root of x. Well, again, we can just call this x to the 1/3. Rational exponents and roots are the same thing. Now let's say we have something like this. Well, what we can do is x to the 3rd, and we're taking the 1/5 exponent, and we use that rule from chapter 1. We'll distribute as an exponent. That will give us x to the 3/5. Let's see here. Let's say we've got this. Well, again, let's convert that into a rational exponent. We still have that exponent 5 floating out there. Let's distribute it as an exponent. So what that's going to give us and that's going to be our answer. So let's do something. Let's say we have this. We'll do another numerical one. We just saw it. Well, for this, we can definitely distribute that as an exponent. We'll get 4/5 times 5, which those are going to cancel. We'll get 3 to the 4th. That's equal to 81. Let's say we have something like this. Now this will get distributed as an exponent to the 125, the x to the 9, and the y to the 6. So we'll get 125 to the 1/3, x to the 9 times 1/3, and y to the 6 times 1/3. Now, what number times itself, if you have 3 of these, gives you 125? Well, 5 times 5 times 5. And 1/3 just means cube root. So this will be 5. 9 times 1/3 is 6. And 6 times 1/3 is 2. And that's going to be your answer. Now let's say we have this. Now these have all the same base. So on the top, we're going to get 5 to the 3/4 plus 1/2 divided by still 5 to the 1/4. Now 3/4 plus 1/2, that's 5 to the 5/4 over 5 to the 1/4. And this will be equal to, again, using those properties, 5 to the 4th minus 1/4, or 5 to the 4 over 4, or 5 to the 1, which is just equal to 5. Now, let's say you have something like this. Now, again, on the inside here, let's convert this out of a root into a rational exponent. So this is what we're going to get. We make this a rational exponent, distribute the 21 as an exponent, and what we'll get, xy to the 7th, distribute that as an exponent, x to the 7th, y to the 7th. And that's going to be your answer. Let's look at a couple more. Let's say you have, okay, we'll do 3 more. We'll do 3 more. So let's say you have this. y2 and 10th root y cubed. Now again, let's turn these into rational exponents. So the y squared is still on the inside of a 1/5. And here the y cubed is going to be on the inside of a 1/10. Then we distribute as exponents. Y to the 2 times 1/5 y to the 3 times 1/10. So again, y to the 2/5 over y to the 3/10. And now we use our quotient rule. Y to the 2/5 minus 3/10, or y to the 4/10 minus 3/10. And that's going to be y to the 1/10. Now that is a valid answer. Now they might, let me see, they do want you to give this as a root. So 1 over n is the nth root, or in this case, the 10th root of y. So let me do 2 more. So any questions about that? All right. The advantage to converting roots to exponents, you can use the product rule from our exponent rules to simplify things. So let's say we have this. So let's convert these roots into exponents. And then let's convert this one. And then we need to distribute. Now we could distribute this, and that'll give us xy squared to the 1/4. And then we can distribute this. So we get, it's going to go here to both of these actually. X to the 1/4, y to the 2 times 1/4. Now let me see how they want to answer this. They might let you, no, oh yeah, they are going to do that. So you could do it this way. You get x to the 1/4, y to the 1/2, or the 4th root of x, square root of y. That is a valid answer. But once you get to this point, actually, let me show you what the book wants. It's not as complicated. So xy squared to the 1/4. You just do the 4th root of xy squared. That's it. So you don't have to distribute that 1/4. Last one. Now, I want to mention something. We're going to get this into the next section. In the next section, you can merge roots if they're the same root. Now, these are not the same root. This is a root 4 and a root 2. So we can't just merge the roots. So what we want to do is convert these, again, into rational exponents. We have a cubed, b cubed to the 1/4. A, b to the 1/2, we can distribute. So we'll get a to the 3/4, b to the 3/4, a to the 1/2, b to the 1/2. Or what we can do, we can break it up like so, and use our quotient rules. And so what that's going to give us, this will be a to the 1/4, b to the 1/4. And let me just see how they want you to answer that. Okay. So what they want you to do, this is valid. This is an answer. But you could do this, and this is what they want you to do in the text. We want you to give your answers in roots. And so you could go AB to the 1/4. That just means 4th root of AB. So what they're doing here, you could say root 4 of A, root 4 of B, but they'd want you to merge those together. So the idea is that in the end, our solutions they're in root form and as few roots as possible. If we could take 2 roots and have them be 1 instead, go from here to here, then take the root, that's the ideal. So that's it for the day. I just want to mention one quick thing with even and odd roots, if you've noticed. Even roots, you have a positive, which is given like this. You also have a negative. And they'll ask for the negative root. So real quick, positive root of 4 is 2, since 2 times 2 is 4. And then the negative root of 4 is negative 2, since negative 2 times negative 2 is also equal to 4. So with even roots, you could get one of 2, a positive or a negative. Now for odd roots, this is the last thing. For odd roots, you're going to have one root, at least for now. When we get complex numbers, it's a different story. You have one root, it's a real one, that could be either positive or negative. It just depends on the number you're working with. So when we talk about the cube root of 8 being 2, it's just cube root of 8. And if you take the cube root of negative 8, it's a different number, but it'll be negative 2, negative 2 cents. Negative 2 times negative 2 times negative 2 is negative 8. So the moral of the story on this, with even roots, you can talk about a positive root or you can talk about a negative root. For odd roots, there's only one root. Whether it's positive or negative just depends on the number you're working with. 8 happens to have a positive 2 as a cube root. Negative 8 happens to have a cube root of negative 2. So even, you got to be kind of careful. Do they want the positive or the negative? With odd, it's whatever root works out. So that's it for today. That's section 1 and section 2. And if any questions, let me know. I'll get this posted as soon as I can. And other than that, have a wonderful day.
Thank you so much.